let's continue the conversation. So now we have f of x is equal to 1 over x squared minus 9, and I'm talking about the interval from -2 to 3, closed interval. Hopefully right off the bat you notice that something odd is going on, because the guidelines that I give you only work if you have a continuous function. And this is not continuous. I know this one will have vertical asymptotes at x being -3 or x being +3. Because that's the place where my denominator will equal 0 and my numerator will not be 0 for those x values. So I'm still going to continue ahead using these rules, but we'll talk about what happens when it's not continuous now. All right. So first things first, I need to find the critical number. So I need to go ahead and get that nice derivative. So I'm going to think about f of x as x squared minus 9 to the negative first, because I do not feel like doing quotient rule right now. So I would rather just treat it as a composite function. So f prime of x is derivative of the outer function times the derivative of the inner function, which should just be 2x. So that means f prime of x equals -2x from multiplying this and this together over x squared minus 9 squared. Right? So remember, critical numbers are where f prime of x equals 0 or f prime of x does not exist. So because I have a rational function, if I'm trying to figure out where f prime of x will equal 0, I really just need to figure out where -2x will equal 0, because the only way a fraction will equal 0 is if the numerator is equal to 0, which turns out to be at x equals 0. If I'm trying to figure out where f prime of x is d and e, well, I can say that that'll occur when x equals positive or -3, because again, it's still the same issue with the denominator here. Okay? So if I'm trying to figure out where this has the maximums and minimums within this interval, well, I guess I should have chosen better numbers, to be 100% honest with you. So I need to test out the endpoints and all these numbers I just found. So I'm going to pause while I fill out that table. All right. So I filled out the table. Again, since we're constricted to from -2 to +3, that's the interval, I don't really have to worry about the vertical asymptote here. However, I do want to point out that I had to resort to a graph because I need to figure out right here where where it's undefined if it's going to a positive, negative, infinity. So I sketched the graph. I know that's going to positive infinity. So I would say that the the absolute minimum is right here in blue, and the maximum does not exist because it goes to positive infinity there.